Alright, so hello and welcome. Here we have another problem. We'll call this text justification. I don't know about this one. This is interesting. So, yeah, here we go. I haven't even looked at this problem, so we'll see how this one goes. We will see how this one goes. Yeah, we'll see. Haven't even looked at it. Did I check it? Got a lot of downvotes. Alright, it's probably a hard one. Really hard one. Given an array of strings, words, and a max width, format the text such that each line has exactly max width characters and is fully left and right justified. You should pack your words in a greedy approach. That is, pack as many words as you can in each line. Pad extra spaces when necessary so that each line has exactly max width characters. Extra spaces between words should be distributed as evenly as possible. I have to read this a few times because when I see problems that I don't understand, it takes me a while to I make a lot of mistakes. We're already a minute in too. Okay, that's fine. Extra spaces between words should be distributed as evenly as possible. If the number of spaces on a line does not divide evenly between words, the empty slots on the left will be assigned more spaces than the slots on the right. For the last line of text, it should be left justified and no extra space is inserted between words. I don't really know what we're doing. A word is defined as a character sequence consisting of non-space characters only. Each word's length is guaranteed to be greater than 0 and not exceed max width. The input array words contains at least one word. Okay, words, this is an example of text justification. Max width 16. This is an example of text justification. Okay, I don't really understand it. Words, what must be acknowledgement shall be. What must be acknowledgement shall be. Okay, I really don't get it. I really don't get it. Note that the last line is shall be instead of shall be because the last line must be left justified instead of fully justified. Oh, okay, the last line is always left justified. Note that the second line is also left justified because it contains only one word. Okay, I think I understand. So being quote-unquote text justified, basically the words on each line, all the words that fit on that line are going to be have spaces in between them, roughly equivalent number of spaces between them and they're saying if as evenly as possible, if this number of spaces on the line does not divide evenly, the empty slots on the left will be assigned more spaces than the slots on the right. So you add one extra space for the slots on the left, from left to right. Okay, I think I get it. I think it's not too hard, the idea, but actually coding this is definitely really challenging. And then the last line of text is left justified completely. So whatever's left over that you can fit, whatever is left that you can fit on the last line, basically just dump it all and add spaces to the right. Okay. Words. Science is what we understand well. Science is what we understand well enough to explain to a computer. Art is everything else we do. Okay, so science is what we understand well enough to explain to a computer. Art is everything else we do. Oh, this is going to be a hard one, huh? Challenging one. How many minutes? It took us 4 minutes just to read the problem. Okay. Here I am thinking I'm going to be solving these problems like half an hour each. Go through, 20 each in a day, 20 in a day. Oh, it's going to be hard, huh? Okay. Words length. The number of words we have at most 300, and the length of each word is 20, at most 20. And they're not all non-empty, right? The words themselves and the number of words, the array of words and the words themselves. Words of I consist of only English letters and symbols. Okay. Max width is between 1 and 100, and the length, of the words less than or equal to the max width, right? So yeah, your width will never be more than the max width. Okay. Right. No idea how to solve this. Not a clue. We can maybe, I don't know. We definitely don't need to modify this. Also don't need to modify the int either. So we can think about this here. So well, how many words can we fit per line? That's a question. That's kind of the key, because we can say, you know, if we knew how many words should fit on a particular line, then we could easily figure out how many spaces we need. But that's part of the problem, is that if it's left justified and right justified, well, what we can do is assume we have at least one space between each word, right? And then right justify one of the words. So this is an example, would be there's 4 for this, 2 for is, 2 for and then 1, 2, 3, 4, 5, 6 for example. But you cannot fit a space between each one. So we could say there's a space for each word except the last word. So it'd be 4 plus 1 plus 2 plus 1 plus 2 gives you 10. And then if we said 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7 plus 7, which is too much, right? That exceeds 16. What we were going to do, so we can do to count how many words we need on each line, we can actually just go line word by word and say, yeah, so I think we can process this word by word, actually. So we're going to have, you could do this iteratively, I believe. Say ret, we're going to say const string s in word, or w in words, and we're going to say current line, current count, we'll say. So current plus equals w dot size. So if current is less than max width, and we could just mw for this. If this is less than or equal to mw, then we're going to say row. And then we're going to update our row, process given word, or given row. And we're going to say a vector of strings, we have ret, and we're going to say not previous, but we'll just say like current up to like sequence, we'll say sequence. So if we're less than equal, if current is less than or equal to mw, if it's less than mw, no, how do we do this? If current is greater than, how do we do this? Let's say we've got a sequence so far that we're of words, right? Some subsequence. You're going to add the next word potentially. So if you add this word and you're greater than the max width, then we're going to process this row. If you add this word and you're equal to this max width, you also process this row with this word. But so if current is greater than equal to max max w, process the given word, the given row, including the word w, without word W. Okay. Otherwise, yeah. So that's the thing. Otherwise, we would continue. We don't increment the row. And so we would say, don't process the row, but append include this word with the current sequence for this row. So we would say sequence.pushback W, and we would also say current plus equals 1. So there's at least one, what do they call that? At least one, each word includes at least one space. Yeah, so each word at that point has at least one space. Now we would say, we're not going to get to processing the row yet, but I think we only need the sequence when we're processing the row. And when we process that row, we're going to increment the row and we set current equal to 0. And similarly, current equal to 0. Process the given row without the current word, the word W. All right, so word W will then be included in the next row. So actually, current is then equal to w.size, and then sequence.pushback W. Yeah, so that's kind of interesting. When you process the given row, you'll set sequence.clear or remove, something like that. See if there's a way to do that with vectors. How are we doing on time? 12 minutes, okay. I think I have an idea of how to do this. Erase. Clears the contents. Yeah, there we go. That's enough. So clear the sequence and push back, right. Clear the sequence too. Alrighty, W will be included, so here it's and then this is okay, so yeah, it's slightly different in each case. Obviously at the end we're going to return ret, and now processing the given row I think consists of, so yeah, every word has at least one space. Once you hit a point where you can't fit, so like, yeah, here this is an example, right? Now to justify, we're going to say we need to know how many spaces are between the characters. So the number of spaces is going to be the current and then like current no space. We could just, that's kind of funny. Current no space is also, this should be +1, and current no space is just W size. And then, yeah, I have to be careful. And obviously there's no, yeah, so word was included. And then here, current no space is plus equals W size. Yeah. So we can actually Yeah, when you include the word in the current no space. So we can use current no space to figure out the number of spaces. And spaces is going to be current no space. The difference between the max width, and now we say total spaces, or n spaces. So int spaces, space. It's going to be the number of spaces divided by the number of words, sequence.size. And then we'll say int remainder, or just r. That's going to be number of spaces modulo the number of size. So for r words, there's going to be one extra space. And I think this will automatically write justify. Let me just see here. So if every word is going to get space to the right, now what's tricky is it's actually going to be it's actually two words where the space is going to be split between. So it's going to be n minus 1. So sequence minus 1 is how many spaces we're going to have, which is a little bit confusing why that is. And the reason for this is we have, so this is n 15, so that's 4 plus 2 plus 2 minus 16 gives you 8 spaces, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, and that's divided between two things, right? It's the spaces are gonna fit between the words, right? So that's why you say sequence minus 1. And so if there's only one string, then actually the space is going to be so that's a tricky thing. We could say they're equal to these things. I'm just thinking modulo 0 doesn't really make sense. What would the remainder be? Let's say 1, really. Well, it should be 0, I think, initially. What I'm saying is whatever the remainder is, that's how many words are going to get an extra space. So if the sequence size is 1, so if sequence.size is is equal to 1, then, if it's equal to 1, we get these two. If it's greater than 1, then we update these two. So that's also a very subtle thing that we want to be careful of also. So R is this, and the other one is space is going to be equal to n spaces divided by sequence minus 1, and then R is modulo. And then now we're going to say for, so we're going to say standard string row string for, or we'll say const string, we'll call it S in the sequence. We're going to say if R is greater than equal to, or R is greater than 0, then we're going to decrement R. We're going going to say not just decrement R, but we're going to say row string plus equals S, and row string plus equals standard string. This is going to get the number. They're going to get the number of space characters, and the number of characters is going to be int spaces, or yeah, spaces. It's going to be space, and then spaces plus plus. So we increment the spaces. If R is greater than 0, increment the spaces, decrement R, and then use space. How much space we need. And if it's 0, and I guess if R is non-zero, so if space is greater than 0. So now, tricky thing here is, we do this for every string in the sequence except the last string. We could do something like this here. Just say if n spaces is greater than 0, and then we can just decrement n spaces minus space. Yeah, it should be fine. Something like this ought to do it. At that point, we won't. The last one won't be placed. Now the last line, the last row, won't be right justified. Or won't, yeah. So this is the justification routine that we're going to do for each part. Hold on. This is without the word W, including the word W. So we're actually going to include the W here first. So we would say, don't increment the row yet. We actually don't need to increment the row at all. I don't think we need to even reference the row. Yeah, I don't think that's used at all. Actually, we don't even need that. Actually, no, we should. I take it back. I have an idea. I know what to do. Okay. Process the row, including the word W, without the word W. So we're going to say, we're going to add to our sequence. So these things we're going to do first. We're not going to clear the sequence. We're not going to update the row. But we are going to say current is going to be including the word W. So we're not going to do this yet. Current no space, we are going to add W size for our current no space. Are going to add to our sequence. And then we're going to do our processing. And this is all the same. Now we clear our sequence, update our row, set current to 0, set current no space to 0, and then not processing the row. So one thing here is if the row is the last row, then we're going to only add one. It's going to be all that's left justified. So we we can write a subroutine just like process last row and just do this and say I have a sequence string which we're going to modify, and yeah, basically we're just going to say for string const string reference w in the sequence. We're going to take, oh no, we don't know if it's the last row or not. That's the problem. That's interesting. Oh, we don't actually need this. I was going to say we could use this row to figure out if this is the last row or not. How much time we have? 26 minutes. We're almost there. I think we got it. I think this is a simple enough thing. We do need to check though if this is the last word we're processing. Yeah, so basically we're gonna have to force processing the last row if it is the last row. So we would say we actually want to do something like this: int I equals 0, I is less than words dot size plus plus I, and then say const string reference w equals w of I. So now, if this is the last word, that means we're at the last row. Now the tricky thing is, don't process the row, but include this word in the current sequence for this row. We would force processing of the row here. Process the given row, including the word w. So if the word is the last word, then we do special processing and then continue. So all of these cases we would process the row. Now this row, if it's the last word, then we need to create a new row. So we process the given row without the word w, and then w will include in the next row. We would say if this is the last word, then process the row here, another row here, and we're going to say process last row, which is just the sequence it takes. We'll say if I is equal to words dot size minus 1, and then so here we would continue. So if this is the last word, then process the row with left justification only, and then finally for here, so we'd say so we do need to be careful. We need to push this sequence, push back here into the sequence, and then we would say finally, if this is the last word, then process the row with the left justification only. And there's really nothing to continue from here, but you would say, yeah, sequence includes that word, and then these variables we don't even use for the last one, the last row. Oh, this is complicated, man. This is not ideal. How are we doing? 30 minutes? Okay. So each word in the sequence, we're going to say final string, standard string, final string. And we just put a space between each, I think. And we're going to actually return ret.pushback. Can do it that way. And finally here, don't need to continue there. Yes, so what we end up doing is we say final string plus equals W, final string plus equals space, and then at the end we're going to pad to the right, final string plus equals M, it's going to be standard string of MW minus final string dot size of spaces and return final string. Something like this ought to do it. Let's see if this works. Right, all the whatever's left is going to be whatever's left is going to be added as space characters. Oh, we couldn't bind to words vi. Shouldn't be WI. Output justification. Oof. Okay. Oh. Yeah. So we forgot to ret.pushback row string, and also over here row string, and here we don't push a row string. Interesting. Okay. Ooh, all right. We missed one. So it should be if it's equal. So let's just see something here. Do we? How are we doing on time also? I suspect that was slightly coded incorrectly. You'll notice, oh no, nope, it was this that was incorrect. Oh, that's interesting. This actually should have a space here. Test 20. Say test 30 or test 10. Actually, I wasn't expecting that. Let's give you this example where like duplicated code is not good. You'll see that this code is more or less duplicated here and incorrectly in both cases, right? But they're slightly different from each other, so I think it's okay to duplicate them. So that's interesting. So each row string is S, increment spaces is space, row is greater than 0, R is greater than 0, increment the spaces, decrement R. R should be, it's initially 0, it updates to end space is sequence minus 1. So 3, 2, so this should be a 1, right? The number of spaces we had here would be 1, 2, 3, right? So 3 mod 2 is 1, so this should be a 1. Plus equals S, and then spaces is equal to space. Oh, this should be spaces, not space. Same thing here. That might be, that's kind of poorly coded too. It should be like another variable altogether. It shouldn't be space and spaces. It should be like or just like, I don't know, X we'll call it. I don't know what to call this. X is better than spaces though. So number of spaces, divide, you got how much space you need per word. If the number of spaces is greater than 0, you're going to decrement the number of spaces each time by the amount of space you're using, which would be X. And we'll go down here as well. How do we end up with the incorrect answer on the second one? The first one was correct. Oh, okay. Oh, I see, because you used spaces, but yeah, that was my mistake. I should have done that. I thought I'd be okay doing that, but that was wrong. All right, so it looks like we got it. Quite the thing. Kind of a mess, quite frankly, but seems to be correct so far. Yeah, really messy. How are we doing? 37 minutes? Okay, looks like it's correct. I don't know, I probably should just go for it. I think I'm going to go for it. I don't really know. There might be some problems here. I think we're okay. I could be wrong. I don't know. Well, no, they'll last. These test cases are handled. A lot of the test cases are handled by these examples. I probably should have just gone for it though. Oh, mistake. That's all right. Yeah, I definitely should have. I definitely should have tested more. Thinking about it, like there's just so many test cases here. That's so many ways this could fail. Yeah, that was silly. That was silly. There's just like a lot that you could make mistakes on here. Instance of length error. Okay. All right. Let's find out where that happens. Also, this should be size T, by the way. Forgot about that. That was an error. So, where is this happening? Debug. Oh man. This is one of those programs that's just not ideal to program something like this. Oh boy. Yeah, I don't know what it was. That went wrong. Yeah, I shouldn't have tried that, to just go for it. That was a bad call. So the last thing we call before we have an issue is 20. And let's say, do we get past this one? 25. Let's try to find out what went wrong before we. It was this one. Okay. right before the runtime error occurred. It's a sequence pushback W, process last row of sequence. So actually, let's do like 21 over here. Was it here that had a problem? Oh, maybe it was this. Oh. Oh, man, that is so subtle. Brother, if that's what I got wrong, I'm going to be so sad. Oh, no, you're kidding. Oh, I didn't even think about that. Oh, no. Really? Dude, I'm going to be so sad if that's the reason that these are equal in some cases. 21, 22, 23. Yeah, that's the problem. Oh, dude, that's so sad. I was so close. It was such a subtle thing. I know what the problem is. It's just you just have to say if MW minus final string dot size is greater than equal to is greater than 0. Call it X. Ah, I can't believe it. Oh, when you sang to me. Oh, when you sang to me. I can't believe it. Alright, let's not insert here. Okay. Sure. Okay. Is that the problem? Oh, it's wrong now. Ooh. Ooh, that's unfortunate. Why, now that's interesting. Oh, my output. Oh, I see. Oh, no. No. That's subtle. That's subtle. That is very subtle. Wow. Wow. Man. Processing that last line. I don't know, man. There's probably some other test cases that I missed. Very likely. I wouldn't be able to guess it. I'd have to go through a bunch of stuff. We already failed the first one. Oh. We got it. Okay. There you go. How are we doing? 45 minutes. Took a while. Yeah, we failed the first one. Yeah, I really should have just tested it. That's so hard though. There's so many things here that could go wrong. Like, look at this code, man. This is wild. It's so subtle. That's like, how do you even guess that? Like, how would I guess something? Like, there's so many things to guess that could go wrong. I could have just tried different test cases. I didn't think about that, to try a test case where the last, that is a test case legitimately missed, where the last row is actually processed here by this processing last row here. I didn't even think about that. Because obviously the code broke. I wrote like just really simple code for that. And the issue is it is simple, but it's easy to add. You shouldn't add an extra space if it fits the bill. If it fits totally. I totally missed that. That was a mistake on my part, actually. That was an interesting mistake. But yeah, like how many? I have 3 different process line, 3 different pieces of code for processing the line. I have one here, which is duplicated here, which I was so proud of myself for getting that right. And then I had another third processing the row for the last row. So I had 3 different pieces of code for that. Pretty wild, man. Yeah, I mean, not really a hard problem overall, in my opinion. Hard in the sense of like there's just a lot of logic in there, and if you write like a lot of code, you can solve it relatively easily, straightforwardly, but in a straightforward way. But definitely, definitely challenging, I'll say. Also, yeah, obviously I kept a vector of the strings, the sequence. I thought that was simpler, just to like dump everything into a sequence and then run through the sequence. I think that's fine. I mean, it uses a bit of memory, but it's okay. I mean, technically, you could write this in a way where, like, I don't know, I don't know, man. I guess maybe instead of a sequence, you could use like 2 integers if you wanted to optimize the memory a bit. So like you could have, the first integer to your set of words, and then you just, instead of incrementing the sequence, you would increment the other, like the ending of the range. So you have a range you're working with, and then when you process the sequence, you just loop through the range. So you don't actually need to copy the strings each time. That is a little bit wasteful, but it's okay. It's not. We don't have to get too crazy about this. We just want to get this right first, and then we can think about optimizing memory later, I suppose. But yeah, so it hurts, man. That hurts. It's bitter. It's like just didn't think about that last row processing enough. I spent so much time thinking about how to get this one right, and I just didn't have. Yeah, man. I don't know. I somehow missed that test case. I thought about it too. I was like, okay, well, we have this one into the last row, and we have this one into another row, right, where it's like on the edge. But I didn't think about what about when the last row is exactly on the edge. What happens then? And I totally missed that. I don't know how I missed that, man. I don't know. I guess this will be a lesson. Yeah. These are like the other kind of like hard problems. Are just like there's lots and lots of like edge cases, I guess, involved. It's like text processing with edge cases, things of that nature. Those are challenging, hard problems. But yeah, thanks guys for watching. Talk to you soon. It's been fun. There's not really much more to say about this one. This is kind of it's definitely a hard one. Took over 45 minutes. Not too bad on my part though. I did okay. I guess I definitely shouldn't have. I don't want to get it wrong though, right? Like you want to get it right. I did get 100% runtime. We kind of expected that. This is sort of linear, sort of as fast as it could go. It's a little slower, a little bit more memory than it needs to, but obviously we don't. And for the constraints, we don't really need to change that. But yeah, thank you again for watching. Talk to you soon. I'm gonna go make some food and hang out a bit. Yeah, dude, this is yeah, okay, all right. Anyway, yeah, thanks for watching. Talk to you soon. Take care.